Hello and good morning to all of you. I welcome you to this video lecture on big data analytics. In today's session, I'm going to discuss about Hadoop ecosystem. So let's begin today's session. The Hadoop ecosystem can be described as a data-centric taxonomy to analyze, aggregate, store, and report data. The various components of Hadoop ecosystem are the Hadoop Distributed File System or HDFS, Hive, Pig, Yarn, which stands for yet another resource negotiator, Flume, Scoop, Uzi, Zookeeper, Mahout, and Ambari. So I'll be discussing each one of these ecosystem components with you. So let's have a quick recap of the history of Hadoop so that we can further, discuss about its ecosystem components. And in January 2008, Hadoop was made its own top-level project at Apache for confirming success. By this time, Hadoop was being used by many other companies such as Yahoo and Facebook, etc. Now, in April 2008, Hadoop broke a world record to become the fastest system to sort a terabyte of data. You can just see these stats here. Oracle took 3.5 days. Teradata company took 4.5 days. Netza took 2 hours 50 minutes, whereas Hadoop just took 3 to 4 minutes to sort 1 terabyte of data of 1024 columns. And what is Hadoop? If we just discuss, it is a top-level project of Apache, and it is an open source software framework for storage and large-scale processing of data sets on clusters of commodity hardware. We discussed about clusters and what this commodity hardware or the commodity machine means. Some of the characteristics of Hadoop are it's open source, that means you can use it free of cost. It's distributed processing, distributed storage. About this distributed processing and distributed storage, I'll be discussing more on it in my upcoming videos. And it is reliable, it is economical, and it is flexible. Now, the Hadoop framework modules, you see the Apache Hadoop framework is composed of the following modules. We'll discuss about the ecosystem components, but basically it has got a Hadoop common module, it has got a Hadoop distributed file system module, it has got a Hadoop yarn module. This file system HDFS module is used for storage of data, and this yarn, it gives you a resource management platform responsible for managing computing resources in clusters and using them for scheduling of users' applications. And this MapReduce algorithm, this MapReduce module would help you to, actually process the data. Now let's come to the working of the ecosystem of Hadoop. You can see the placement of the various components. There is this Hadoop distributed file system. Then there is HBase, there is Hive, there is Pig, there is Mahout, there is Uzi, the workflow manager. Zookeeper is there. Then Scoop and Flume are there, right? So I'll be discussing each one of these components in detail with you now. So when we talk of HDFS, the Hadoop Distributed File System, it is designed to reliably store very large files across machines in a large cluster. And it is inspired by the Google file system, the white paper that Google wrote way back in 2002. Now, it distributes large data file into blocks, okay? And these blocks are managed by different nodes in the cluster. And each block is replicated on multiple nodes. And name node, it stores metadata information about files and blocks. So this is just a summary of what HDFS does. When we actually start learning about HDFS, we'll discuss in detail about its architecture and how it stores and allows the manipulation of files. Next is the MapReduce. MapReduce is the analytical algorithm part of this Hadoop ecosystem. And it has basically got two things, the mapper and the reducer. And this too we'll discuss when we discuss MapReduce. Next is the HBase, okay? Hadoop database, HBase is the Hadoop database for random read-write access. Now its features are, it's a NoSQL database. That means NoSQL means it does not only have SQL, it deals unstructured data also. And strongly consistent read and write. automatic sharding, automatic region server failover. It is integrated with Hadoop and HDFS. Okay, so you can just read all these features since HBase is not a part of our syllabus. So you can just have an outline what it is and what it does. No more details than this are required. Then when we discuss of Hive, so Hive gives you a SQL-like queries platform. Okay, so similar to the SQL, we have got the HQL known as the Hive query language. Okay, so it is a SQL-like interface to Hadoop, and its data warehouse infrastructure built on top of Hadoop provides data summarization, queries, and analysis. And the query execution is via the MapReduce. Okay, and it was developed by Facebook and also used by Netflix, CNET, Dig, eHarmony, etc. So Hive is quite a popular ecosystem component of Hadoop. And since this also we don't discuss in detail in our syllabus, so you can just have just see the features of Hive. Next is Apache Pig. It is a data flow language in a compiler. And we are going to discuss Apache Pig in great detail as it's part of our syllabus. And basically, it's a scripting platform for processing and analyzing large data sets. And it allows to write complex map-reduce programs using a simple scripting language. Now, what is the advantage of Pig is that otherwise, if you don't have Pig, then you need to write your queries in Java, which is a typical, programming language, and programmers are usually, sometimes in awe of Java, right? So it is a high-level language, English-like interfaces there, and it's a data flow language. Okay, it's an open source project. You can use it free of cost, and it was developed by Yahoo. And remember, we're going to discuss Pig and how it analyzes data, the queries, and all the things we're going to discuss in detail about Apache Pig. Then Zookeeper is for coordination service for distributed applications. And Zookeeper is a centralized service for maintaining configuration information, naming, providing distributed synchronization, and providing group services, right? Then next is Flume. Now, Flume is a distributed, reliable, and available service for efficiently collecting, aggregating, and moving large amounts of streaming data into the Hadoop distributed file system. So, when you want to import or export data from Flume into HDFS or from HDFS to Flume, then we are talking of unstructured data, right? Log data. So, when you want to do that, when you want to move unstructured data into Hadoop, you can take the help of Flume. Similarly, Scoop is there and does a similar job like Flume. The only difference that it deals with structured data, importing and exporting structured data within RDBMS and Hadoop. Then Oozie is a workflow scheduler, okay, and where the workflows are expressed as directed acyclic graphs. Oozie runs in a Java servlet container Tomcat and makes use of a database to store all the running workflow instances. Their states add variables along with workflow definitions to manage Hadoop jobs. Okay, so basically Oozie is a workflow scheduler. And then two more components are left. One is Mahout and one is Ambari. So we can just shift to our PPT to discuss that too. So when we talk of Mahout, Apache Mahout is a scalable machine learning library, right? It is a machine learning library of Hadoop and is used for predictive analytics on big data. Okay. And Ambari is designed to make Hadoop management simpler by providing an interface for provisioning, managing, and monitoring Apache Hadoop clusters. So when you need to monitor your Apache Hadoop cluster or manage your Apache Hadoop cluster, then you can take the help of this Ambari ecosystem component, right? So we can just shift here. Now I'll discuss some Hadoop advantages with you. The first obviously is unlimited data storage. It is a scalable architecture, so you can add more nodes to the cluster and you can store more data. Okay, and the processing speed is very high, and it can deal with all varieties of data, whether structural, unstructured, or semi-structured. Right. The disadvantage of Hadoop is that if the volume of data that you are dealing with is small, then Hadoop is not a good choice, right? And we need to be, it is meant to be for reading of streaming data, so huge amounts of data, right? and Hadoop should be used only for batch processing. Okay, and Hadoop is not used for OLTP. Okay, because it's not an interactive. You cannot edit files in Hadoop. You can store a file and then you can read it at a very fast pace, and you can analyze it. So that's all for today's lecture. That was about Hadoop ecosystem components. And in my next lecture with you, I'll be discussing about Ubuntu and some commands related with Ubuntu. Till then, keep watching the videos. Thank you very much.